First, we would like to understand the effect of the AC or DC current on the human body. The reason for this, we will understand the effect of AC or DC, then we'll understand why do we use the earthing system. So the effect of an AC or DC current on human body depends on three main factors. The first one is the amplitude of the current, the value of the current which the human is exposed to. Number two, the duration of the current passing through the human body, the time in which the current passing through the body, and the frequency of the current passing. It is DC of 0 frequency or AC with 50 Hz or more. And number four, the direction or the path of the current. So let's start by discussing each of these factors. So the first one is the effect of the electric hazards or the current on the humans. For example, if we are talking about the AC current and its effect on the human body. So for a current 1 milliampere, you will feel or a slight sensation of the current. Okay, you will feel a small current. Here from 1 milliampere to 5 milliampere, 5 milliampere representing the maximum current which is still harmless to the human. Okay, so 5 milliampere you cannot sense it, or you cannot even have any harmful effects. From 10 to 20 milliampere, you will find that in this case the loss of muscle control. In this case you will not feel, you cannot control your hands muscles, and you cannot let go the electric circuit. Okay, so when you are, the electricity captures you and you cannot leave it. So at 50 milliampere you will find that there is a difficulty of respiration. From 100 to 300 milliampere, the breathing stops, and eventually it would lead to fatal, or it is fatal, which will lead to death. From 1000 to 6000 milliampere and above, of course, the internal organs and the tissues starts to burn in the human body. So here we have the value of the current and the effect of it on the human body. So now let's see the effect of the current with respect to time. So if we have a current from 0 to 0.5 milliampere and providing it for continuous time, then it will have no effect. So from 0 to 0.5 milliampere to the human body does not have any effect for any range of time. Starting from 0.5 to 5 milliampere continuously too, you'll find that involuntary muscle contraction, but no harmful effects on the human. From 5 to 30 milliampere, now if we happen that the human is exposed to this amount of current for minutes, then this will cause muscle contraction and difficulty from separation of the circuit, or difficulty of separation from the circuit. You cannot let go of the circuit. Now if the current increases to 30 to 50 milliampere for just seconds, this will cause difficulty in breathing and loss of consciousness. For more than 100 milliampere and exposed to more than 20 milliseconds, this will finally lead to death. So in this table we see the amount of current and the time exposed to it and its effect on the human body. So we'll see that in the earthing system we need to protect the human against these values of current, and we'll see that how the earthing will affect or protect the human from this amount of current. But first let's see the maximum current that the human can withstand with respect to time. So approximately we can say that the current in which the human can withstand with respect to time is equal to 116 milliampere over the square root of the time in second. So for example, if we have a time of 10 seconds and would like to make the human or the amount of current that the human can withstand in a time of 10 seconds, so we'll take 10 and substitute here. So 116 over root 10 will give us the amount of current that the human can withstand during 10 seconds without any damage, which is 36.68 milliampere. So if a human exposed to this amount of current for just 10 seconds, the human can withstand. But remember that 10 seconds is the maximum current. Okay, so this formula can help us to get the time or the current that the human can withstand with respect to time. So the effect of frequency of current. So AC or DC currents, both of them can cause damage to the heart at high enough levels. But the AC is much worse than the DC. Why? Because for AC, we will need 30 milliampere as a root mean square value, as an RMS value at 60 Hz. Okay, but for DC, we will need 300 to 500 milliampere of DC current to produce the same effect of the 30 milliampere of AC. So you will find that the AC is more dangerous than the DC. As you will see that the amount of current needed here is 30 milliampere only, but in case of DC we'll need 300 to 500 milliampere. This means that more DC current is required to produce the same effect of the AC. The low frequency AC current is more dangerous than the high frequency AC. So the 60 Hz AC current is much worse than 1 kHz AC power. Now, the effect of the direction of current. The current can pass through the human from foot to foot, okay, from the left to right or the right to left, and can pass from left hand to right hand, for example, and can pass from left hand to feet, one of the feet, and can pass from the right hand to the feet. But the question is, which one of these is the worst case? The worst case is hand to hand, for example, from left to right. Why? Because from left hand to right hand or right hand to left hand, the current passes through the heart. And also another case which is the worst is from the left hand to the feet. Why? Because from left hand to the feet, the current will pass through the heart. So the worst case is hand to hand or left hand to feet, as both of them will pass through the heart.